Good morning, friends. Today we will be discussing the most important topic in the Verilog, which is the hierarchical modeling concept. Okay, so in this hierarchical modeling concepts, what we have to observe is that the approach which we are going to use in designing any of the application or the hardware. Okay, so generally in the Verilog, we have two approaches. First one, we call it as a top-down approach, and the second one, we call it as a bottom-up approach. Okay. So top-down approach and bottom-up approach, what are those? Okay. When you are going to go for any digital design, right? So you need to go from the top to the bottom, right? So what we find in this top to bottom means is the components, the gate level, the functionality level. So from the top to the bottom, you're going to go, or you're building the components from the scratch or from the bottom to the top method, which we are going to observe. So we have one example which will link into that one. So either of the two approaches which we can use in building up of any of the digital design. Okay. It explains differences between the modules and the module instances in very long. So we need to identify which are the input, which are the instances, like keywords, like the variables. So that description, it should be clearly mentioned. So we take up an example, then it will be very easy for you to understand. So in this approaches also, you will be having four level of abstraction. Right. At the initial, we have seen that you have at the initial abstract level itself, you are going to change. Right. So you, if you want to change any programming style, that it is allowed. Okay. So in this very law, we have four level of abstraction. What is the behavioral type? What is the data flow type? What is the gate level type? And one last is your switch level type, right? To represent the same module. So one simple program, right, which you are going to write for the hardware, that program you can represent in these four different ways. Okay, four different abstraction level we call it as. What is behavioral, what is data flow, what is gate level, and what is switch level. So what are these types? We'll take one simple example, then write that same program in these four different level so that it will be very easy for you people to understand. Then last part is your describe components required for the simulation of a digital design. Define a stimulus block and a design block. Explain two methods of the applied stimulus. So here the hardware, whatever it is there, it is been written into two types. One, we actually write our main program, and second part, wherever we are going to give the conditions. Okay. Best example I can take with respect to this one is the full ladder. Now, full ladder, we will be having sum and we will be having carry. And what are the inputs for this full ladder? You are having input A, you are having input B, and you are having input carry in. So, what is the expected output? Your sum and carry. Now, when I am having three inputs, so I am going to get eight combination. So 8 combination 0, 0, 0 to 1, 1, 1. These are the different kind of inputs, valid inputs. Invalid inputs, what is the output, that also we will be taking care. Now for this valid inputs, you will be expecting some value and you are expecting carry value. Sometimes it will be 0, 0, sometimes it will be 0, 1, sometimes it will be 1, 0, sometimes it will be 1, 1. Right. So to write this condition, for your program, you require the simulation block. That we call it as a stimulus block. So over a period of time, you will be also observing what it is. Okay. So now understanding what is the hierarchical modeling concept. So we will begin with the first approach, which is the top-down design methodology. Okay. So as you can see, it is starting from the top level, which we call it as a top level block. Then from this top level block, you are having the multiple sub block. Okay, sub block 1, sub block 2, sub block 3, sub block 4. And these sub blocks also is having some multiple things, like we call it as a leaf cell. Okay. Suppose say if I want to implement a full ladder. Okay. Now that full ladder will be at the top level. Okay. Now full ladder you are going to implement using the half adder. So at the sub-block level, you will be having half adder 1, half adder 2, because 2 half adder is required for the full adder. That is the thing. So no need of sub-block 3 and sub-block 4. Only half adder 1, half adder 2 is sufficient. For this half adder, again you will be having some XOR gate, some AND gate, some OR gate. And those gates are nothing but we call it as a leaf cell. Right. So this is the approach which we call it as a top-down approach. Okay, so it is starting from the full adder, then half adder, then to the basic gates. So if your design flow is from top to bottom, we call it as a top-down design methodology. Okay, next one is your bottom-up design methodology. So I want to implement again taking an example of the full adder. So I am going to use XOR component, these components, okay, XOR and all those things, and I will build a half adder. From these half adder, I'm going to build the full adder. So this approach we call it as a bottom-up design methodology. So these are the two basic approaches which we can find in the hierarchical modeling structure. One is the top to bottom approach, one is the bottom to top approach. So whichever is suitable for your application, you can choose your hierarchy model in building up the things. Okay. So this is one basic hierarchical modeling structure which we can form. Okay. Next, we will continue with an example.